Okay, can you see it?
Good evening, everyone. Welcome to the 27th meetup of Kaggle Days Meetup Delhi NCR. I'm Vaibhav Chawla, part of the organizing team, and we are proud to host Mohammed Rizin, a Kaggle competition master at the age of 16. During this meetup, we'll be discussing about tricks in computer vision and ensembling. So,
Rizin, could you please unmute yourself?
Hi, can you hear me?
yes, we can.
So can I start?
Yeah, sure.
Hi everyone. Hi all. So my name is Mohammed Rizin. Today I'm going to present about in the topic about tricks in computer vision and assembly. So first of all, I'm a high school student, and I have completed university master, and I'm 39th place globally in Kaggle competition tire. I have won 2 competitions, and I have won 8 medals, 3 golds, 4 silver, and 1 bronze. So let's get into the topic. So I gonna give a small agenda for my presentation. First, I'm gonna talk about pre-processing and validation. Then I will talk about modeling and other modeling tricks too. Then optimizer, scheduler, then post-processing and other tricks, ensembling, bad practices, which is in computer vision tasks. And I'm gonna make a quick walkthrough to my previous solution. So let's get into the topic. So first of all, pre-processing. So pre-processing and
Rizin,
validation.
Rizin, we are not able to see the screen slide changes. Could you please check? Like we could see the small slides at the left of the screen, but we could not. Yeah, we are now at that pre-processing and validation. Okay, thank you.
Can you see now?
Yeah, we can see now. Yeah.
So I gonna talk about pre-processing and validation. So first of all, when you get into a computer vision task, like all other tasks, we need to explore the data, try to read it and understand it. So if you understand it, if it is most computer vision tasks are image data, maybe it is given in BMP format or DCOM format, example X-ray. So we need to try to read it with the different libraries, and we need to understand what the data is, what all data they have given. So we need to try to understand them. The next thing we need to do is to convert the data into easily readable format. Like if we get for X-ray, we usually see DCOM format. So we need to change that format to GPG or PNG format. So if we load DCOM in a dataset class, it would be taking a lot of time to train. So it is a common practice that converting DCOM into GPG or PNG files. The other thing we need to do is like using augmentations. But for augmentation, we can use augmentation but never hurt the model. I mean, if we just use augmentations and we lose the important informations from the image, the model would have to classify so hardly. I mean, the model could not classify the given label. So we need to give augmentation wisely. So augmentation can improve the score, but if we hurt the model, it could decrease our score severely. So next thing is splitting the data. It's coming to the validation stage. So there are a lot of methods for validation. There's a lot of validation methods like stratify k-fault or grave k-fault or k-fault. There is a simple train test split, but I personally prefer to use any k-fault methods. And if you try to explore the data, as I said, and if you split the data in the same distribution as the test set for the train set, it will be the best choice you will take for your model. If the model is like image captioning, or if it has some other labels, so you need to tokenize, or you need to pre-process them also. uh, can you see me? Can you see the other screen? Hello. Hello.
Hi. We can see the screen, but we cannot see the your camera through your camera.
Can you see the modeling screen?
Yes, yes, yes. We are seeing the modeling screen.
So the next thing is modeling. So modeling is a very interesting part. For each computer vision task, you may need same backbone but different neck. That's how what I do in my projects. But for backbones, we have efficient net family, ResNet family, or we have NFNet family. There is efficient net V2 family also. So we need to try to use different networks from them. I mean, if we choose one network from efficient net family and ResNet, it would be a diverse for Ensembling. I will be talking about it in a couple after some time. So the next thing is next. So next is what is different for each computation task. If it is a classification task, you have a fine layer as a symbol dense layer or linear layer. For segmentation, you have UNet or FCN next. There's detection head and FPN. So for each task, it has different next but same backbones. So for any competition, modeling part is like breaking into the problem into different parts. So for example, if it is image captioning, the backbone would be an efficient net, and the neck would be an LSTM or RNN network, glue network, and some like. So we have other modeling tricks which can improve the score, like changing the final global pooling layer to GEM or SPOC or etc. And there is another layer like mesh layer, like you can just actually swap the mesh layer to a switch layer or any other layers. And you need to do a lot of experiments, and you need to go through a lot of research papers which is the best combination. And you need to understand if there is a lot of classes, we need to use metric learning layer like Adacos or Cosface or ArcFace. So another most important part is optimizers. We know what optimizers are. It's a functions which adjust the weights of a neural network by a factor of a learning rate with respect to the loss. So we need to have a good, if we have a good optimizer, our model will get very optimized very fastly. So usually people use optimizers like Adam or SGD or ADA Delta. So there are some other optimizers that might work too, like Adam W, Adam P. So look at her optimizers, as you can see in the image on the right bottom. So there is look ahead has a very great loss. It optimizes the model very much. So try to have a good learning rate. Next thing is scheduler. So learning rate schedulers is just like just decreasing or increasing the learning rate according to the predefined schedule. So the common learning rate schedulers are step decay.
We could not see your slides. We are still stuck at modeling slides itself. Are you to any other slide?
Yes.
Uh, we are only on the.
Can you see it now?
Yeah. We can now see the schedulers, but initially we were not
Uh,
able to see the presentation of the schedulers. We were stuck at the slides of modeling. So no worries. Like you can continue.
so common learning rate schedulers like step decay. Can you see it now?
Yeah, we can. We are on schedulers.
Yeah. Common learning or cosine annealing LR or radius LR on plateau or one cycle LR. That is
Uh, you are not audible. I think there's a network issue. The speaker is having a bit of network issue. Uh, we are sorry for the inconvenience.
So we are trying to get in touch with the speaker. Due to some network issues, he is not able to present his screen, and there were some lags that were coming from the speaker's end. We are trying to get in touch with the speaker and try to see if we can rectify it, or otherwise we will be updating you about the next status of this event within like next 3 to 4 minutes. Please bear with us. Thank you.
extremely so. Hi.
Hi, there was a
And
bit of a network issue,
yeah.
so you got disconnected.
So where did I stop?
You were telling about schedulers. It was on that slide. Your screen is not visible.
I'm sharing. I'm going to talk about schedulers again. So, learning rate schedulers actually do just adjust the learning rate for your in between the training. But it might just actually increase the learning rate or decrease the learning rate according to the predefined schedule. The some of the basically used common schedulers are like step decay, exponential decay, or cosine annealing, or there are a lot of them. You need to experiment each of them. So one of the most important schedulers, which is used in most of the Kaggle competitions I see, is global warm-up scheduler. So try to use it in your problems too. So another one of the important tasks in computer vision is called post processing. So the post processing actually do like if after the model predicts, you need to filter out, or you need to actually filter out some of the samples which we know it is not. I mean, if you check the predictions and uh, try to check where the model gets bad, and try to understand what is happening out there. I mean, if the model predicts a label as very bad, you can have something that is useful for that model to predict this label very much. That could actually improve your score in the training stage, and it also improves your inference stage too. And then if you have some kind of, we cannot do modeling, or you can just actually use a KNN to filter out some of the labels too. If there are so many classes also along with a negative class, I mean,
Rizin, we could
if
not
the,
see the slides changing.
where is it?
It's now currently on the schedulers. Yeah, the way you are changing now, keep it changing during the session too. Okay.
Okay.
Okay. Thank you.
So try to check your predictions, and where it is getting bad, so try to fix there, and come up with new ideas out there. So if there is a new so many classes with a negative class, I mean, if there is a 10 to 15 classes, like if they no COVID and there is a COVID has a lot of other labels, so you need to predict if you have a classification network which predicts if the person has COVID or not. You just actually filter out negative samples from it and just actually do inference on the positive samples and find the labels for them. So it would actually save your time. Also, it improves your score a lot. And another thing is pseudo labeling, which can improve your score a lot. So pseudo labeling basically means you just actually try to label with your try to label an external data with the existing network. Like it could be external data or a given test data also, and train your model on that data set with these pseudo labels. So it can improve your score, because in last one of the problems, I just actually used pseudo labeling. I did almost like 4 times pseudo labeling, and each time the score improves gradually. So the next thing is I'm going to talk about is ensembling. So as you know, ensembling actually it prevents your model from overfitting. It actually finds the prediction from different diverse networks. As I said, if you have different kind of backbones, like if you just actually use efficient net, you have diverse number of models, and your prediction will be actually a best one of them. So you need to ensembling them will make your score more perfect. So some of the ensemble tricks are, there's enormous amount of ensemble tricks. I'm gonna list out some of them. Uh, Enormous amount of ensemble tricks. So I'm going to list out some of them. Like for classification, we have simple averaging and weighted averaging also there. Like we just actually weight some model value. And for stacking, I will just actually talk about them. We can vote if 3 models vote for a single label. We can just actually give that. If more models vote for a single label, we can just actually use that label for that image. For detection, we have weighted box fusion, which is a famous library by ZF Turbo, and we have non-maximum suppression, etc. So for segmentation, we have symbol feature map. Like classification, we can just actually use symbol averaging. We can just actually vote or weighted averaging, or we can do a lot of other ensemble tricks out there too. So I'm going to talk about stacking. Stacking is like you have a different lot of models, like you have an efficient net, RusNet or NFNet. So we need to find which is the best model for that label. I mean, for some classes, like for like if for some labels, for label 1 it is good for good to use model 2. We have a decision making model, like we could just actually use an LGB model or random forest network there. So it takes the prediction from different models and it trains with the same ground truth level as we did for the deep learning models, like them. So for this network, it takes a prediction from the models and it try to find the best prediction for that label. So this might improve your score, improve your prediction very much. So this classifier can understand which model to use for each label. So stacking actually did like that. So for detection task, we have WBS and NMS. So as you can see, WBF for WBF, we it actually just actually taking the average. So it might be it is a weighted average. And for NMS, you see the most confident box. This one is the most confident box. So NMS produce a box something like the most confident box also. But WBF is a very good method. I'm gonna talk about my quick solution where WBF is used a lot. So for segmentation, you can just actually use a voting. See, if you can see in the predictions, like for one model, it predicts um, almost like a voting, and the middle model has a some weightage also. So if the label is, if the mask is there for each three of them, they can keep here, and model 3 has a special weightage also there. So like in this part, the other models do not have predicted their mask, but this model predicts this mask, so it predicts it has a weightage to keep this one also. So some of the bad practices followed in computer vision are spending too much time in modeling. Spending too much time on modeling. So modeling is an interesting part, but modeling cannot bring a huge improvement, but can bring improvement, but never spend a lot of time. I spend personally a 15% of the time in modeling. So I prefer. Most of the time I use 20% of the time, but I prefer to use 15%. And spending too less time on post-processing, validation, and pre-processing, which is the most important task. So you need to spend a lot of time to validate which is the best distribution for the test, which replicate the test set. So you need to validate in the same way. So try to do the validation. I spend too much time. I spend almost the 70% of the time on this one. Then the rest of the percentage of the time, you should never spend too much time on ensembling too, because ensembling has it cannot bring a large, it can bring a large improvement in some cases, but most of the cases it might actually lose your time, but don't use so much time on it. So if you are doing a Kaggle competition, never believe on the public score, public LB score, because public LB score is sometimes on the less amount of data, maybe biased with some labels. So if your model is too much to that level, so your score will be too good in the public LB, but when it comes to the private LB, it might decreases, it might pull you down to the end. So always believe on your validation score. So that might help you win and competition, and the organizers get the best model of them. So the splitting the data into valid and train test split. I this is my personal opinion, because I don't like to use a train test split in most of the cases, because k-fold validation is the best, because it gives, we can just actually train on different models and we can just actually ensemble them, so it can improve score. But it's also good practice. It gives a stable LB score to me. This gives a good validation score. So try to use Simba, try to use k-fold. Don't go for train test split, but some cases, like if you have a million or 4 million images, so in that case using a train test split will be the only way to use. So try to use k-fold validation methods in most of the cases. And the next thing is I starting a problem without knowing anything about the data. I mean, if you didn't explore the data and you just actually start the problem, you cannot actually exploit the data. So try to understand the data, then only you can exploit it. So first of all, when you start the problem, you just actually explore the data. So this was my previous one of the competition leaderboard we have first. So in this competition, we used a whole kind of ensembling methods like hello, can you see my screen?
Yes, we can see your screen.
Okay, thanks. So in this solution, we use our teams used almost full of ensembling methods, just ensembling. In that competition, ensembling was a very big advantage and give a boost in the score to make us in the top first. So uh, in this we have a fully validated stage, partially validated stage, not validated stage. So we need to be validated. So our score will be more stable and it will be genuine. So we use like almost a lot of ensembling, WBS, NMW, NMS, all the methods of ensembling in object detection, and we did in all the tasks, and finally we got the score to be first. And, this is why I said ensembling is important, but some cases you need to this fully validated stage actually stabilized our solution in some cases, you can say. So thank you, Kaggle Delhi. Thank you for listening. So sorry for the inconvenience about the network issues.
Well, absolutely no issues. It was a very great, insightful session. And we have a few questions in the comments. Uh, Viral Mamnia is asking what could be the best model to train dense object detection model to detect around 200 to 300 objects.
Um, if if you have object detection problems, I say we should use YOLO networks, because YOLO is the best network I have ever seen in my experiments. But you can say YOLO is the only one. Efficient net might work, but if there is 200 to 300 classes, you can just actually use a metric learning layer at the end.
So there's a follow up from Viral. Usually, models required a particular image dimensions for training as per architecture, which reduces the image quality and doesn't help to achieve nice precision. So, what are your comments on this?
He, reducing the image size uh, reducing the image size might improve your speed in the model, but sometimes it actually decrease the performance of the model. But uh, sometimes it reduces the quality, so that it reduces the performance of the model. So I 416 is a good good dimension of the model, but it depends upon the data given. So try to use most of the cases big image sizes. But if you have a memory problems like GP is not enough, so you may need to swap into smaller image sizes.
We have another question. Hi. Uh, there is again asking, so is it possible to train actual image with this effect model training, and do I need to add more layers in model architecture to train on such high resolution image?
If so we can if the image size of the actual image size of the whole samples of your data set is same, so you can just actually um, give the same actual size to the model. But if it is a variable sizes, you need to resize into a single constant sizes. I think in my experiments, I never added a new layer for the if we are actually increasing the if we are increasing the image if we are increasing the image sizes, we don't I didn't actually added any layers. But if the dimension of if this channels are if the model has if the given image has 4 to 6 channels, like we just actually change the parameters in the first layer, that's all.
I hope your query is answered, Viral. So Lucas is asking, hi, which model or trick or hint you would advise for detection task with about 2000 classes, where about 50% classes in train set have very little examples, like 5 to 20 examples per class.
As I said, if you have a lot of classes, um, your model could actually maybe can detect the samples, but it able to have a very hard time in classifying it. But YOLO would work. But if you add a simple metric learning layer like arc phase or cost phase, it is very good for a lot of models. Like if there is 2 lakh million labels, so it 2 lakh labels, arc phase metric learning layers actually works too good. So it doesn't depend on the number of samples, but if you are using the simple softmax layer at the end, it might give a good score, but not good, better than the metric learning approach. Is that clear?
So we have another question from Gino Rohit. How much time do you spend on Kaggle, and how do we make Kaggle less overwhelming? And he has given thanks in advance.
Can you repeat the question, please?
Yes. How much time do you spend on Kaggle, and how do we make Kaggle less overwhelming?
So actually spend a lot of time in Kaggle, like almost 7 to 8 hours. So um, so uh, so can you hear me?
Yeah, we can.
It's been stuck. Uh, I didn't get the second question. Sorry.
So should I repeat or?
Yes. Yes.
Uh, so how much time do you spend on Kaggle? This is the first part, and the second part is how do we make Kaggle less overwhelming?
I didn't get that question actually clearly.
Yeah, like he is asking, the person is asking that how much time do you usually spend on Kaggle, to which you replied that you try to spend 7 to 8 hours around Kaggle and to explore the things. But the next thing is asking is for beginners, like the person who is trying to start Kaggle, sometimes it becomes a little bit too much tough for them to go. Like sometimes they become confused, sometimes they become very nervous that how to go ahead or how to do those things. So how do you tackle those kind of situations where you are nervous or where you get things a little bit tough on Kaggle?
So in that case, for every this was a case I was same as was starting. I was actually looking the previous solutions and try to spend a lot of time on them. So try to take their codes, and actually I was running. So this gave me a confidence, but never gives a very great score. But I just actually experiment a lot, and maybe some in the Kaggle competitions we need to find the magic. So till that we'll be overwhelmed. We'll be actually confusing what to do, and so we need to find the magic first. So it would be easier. But if we didn't find, we just actually could learn a lot from them, because after we finish the competitions we can learn from the top solutions.
Got it. Thanks for the answer, Rizin. And like, how have been your journey around computer vision? Like, from where you started, or what were your resources when you started computer vision? A lot of community members might be interested in knowing how your computer vision journey was, from where you started, and any interesting facts around your journey, like any interesting competitions or any interesting learnings you had during computer vision learnings and other stuffs.
Actually, I just actually had a just a thought to learn this thing, but when I just actually started this one, I thought I saw that I need to learn the mathematics. So I just actually take the mathematics and I just actually go through. Then I just actually take Andrew Ng's lectures. It was one of the best lectures I see in YouTube. So it is the best lecture. It gives me how to. I didn't understand how to actually concatenate this mathematics with this machine learning. So I get in these lectures I got an understanding how to use and how to use this mathematics. But then actually learn and I just actually take some of the courses online. Then I had only then I just actually started Kaggle. Then it was a 1 year journey. Like I was learning from top solutions and just actually implementing the next competitions. Might work, it might not work. So it was a trial and error for that time. Then finally we get an understanding how to use each task in each problem. So that was my journey.
Yeah, like quite interesting and quite realistic too, right? This is somewhat student usually goes through, and just a personal question around that, like how do you manage the school life as well as caggling? Because a lot of the students are thinking that how come a student who is still in his high school devotes a little bit of time around caggling, and how do he manage stuff? So around that, how your school life looks like. Usually now it's an online format, but how usually you manage around the school classrooms and the Kaggle learnings that you have?
Mm, the stage I was starting, it was actually I was in grade 10 when I was starting, so it was a bit hard at that time because the board exams are coming, so it was a bit hard to spend more time on them, Kaggle. But I still got a chance. I almost like 4 to 5 hours, or sometimes I just actually take more than that to Kaggle, and I just actually learn. The classes are online, so I just actually finished the classes and I started doing without not, I won't study anything for the school. So I basically spend more time on the Kaggle in schooling if the school was closed. So if the school were open, it would be a hard time for me to concentrate on
Yeah.
Kaggle.
So like unintended benefits of being at home. So no worries. It's like and like ensembling. When we talk about ensembling, it's usually like students directly jump into ensembling at the first place. Like whenever they see, it's like you haven't even mentioned that ensembling should not be the very first choice at the first place itself. So like, why do you think ensembling people go into this ensembling stuff at the very starting? Though it's not very much suggested by a lot of folks. Like in any suggestion around that, like you also gave a idea to tackle with ensembling at the start. So any suggestions on ensembling at any point?
Can I make the clear last
And
part?
your voice broke for just a little bit.
Yeah. So like
Can you repeat?
alternatives of ensembling, like you try to do ensembling and you try to go into usage of ensembling at some point or the other in your project. But usually the learners who are just starting, sometimes they feel ensembling a little bit hard at the first place. So what would be your suggestion, your alternatives to ensembling for them?
Um, First time like others, I when I just actually start the competition, I take the public notebooks and just actually ensemble. So ensembling is a simple task, but if the data if we just actually could take the submission file, or we could just actually take the simple model output, and you could just actually do ensemble. But most of the cases, like some competitions will accept submission files. So in that case, you need to take the submission file and actually decode it into a numerical format where you can do ensembling easily. So try to change the submission file into that case and ensemble from there. Or you could just actually take the output from the model of different models and just actually mean the mean the predictions.
So we have a
Yeah.
question in the comments. Lucas is asking, have you tried visual transformer architectures for object detection in Kaggle competitions?
uh, I never used in object for the object detection. I never used transformer based networks, but it might like in the last competition we used YOLO transformer. It gives a great improvement in the score, but it's actually mostly similar to the simple networks, but you should I don't say for a single problem it is the best one of them, but you should do a lot of experiments for each computer vision task.
Yeah, got it. And any interesting Kaggle competition you worked on, or your learnings? Like, what were your major learnings from any Kaggle competition that you were working on?
One of the best competition I liked was the lift motion prediction self-driving car competition was there. So this was one of the learning competition where I actually did every stuff I wanted to know. Like I was starting by do PyTorch at that competition. So I learned how to use diverse kind of model, how to ensemble them. It was my first competition, which I spent most of the time uh, doing CAD.
Got it, got it. And it's like I was going through your LinkedIn profile. It's like you are trying to research into healthcare domains and other sectors. So like how this come shift around healthcare? Like any specific problem statements you love to work on, or any other thing that you love to research in the healthcare domain?
It's not healthcare domain is like helping the people. That's all was my motivation. But I like to work in the medical and physics field. I like to combine them with AI. That's my uh, ambition.
Nice, nice, nice. So like if you were to combine a healthcare problem statement with AI, what would be your first approach? Like let's say you want to solve something specifically in a healthcare domain. Like I want to solve how people do this stuffs in healthcare. So any specific thing that you want to solve with AI in healthcare at the first place?
Um, I I don't know it's possible or not, but I imagine that I could build a surgeon, a robot surgeon, to
Oh,
do a
nice,
surgery.
nice, nice. It's like because I was just curious about the like applications of AI in healthcare. Due to COVID, we saw a lot of applications of AI in healthcare. So like definitely there is a long way to go around healthcare and AI. So best of luck for your future, and thanks for your talk today. It was really useful, and we hope that the community members also get to learn from you, and do share your learnings as you go on your social media profiles, and we would be very happy to learn from you. And all the best for your achievements in the time to go. Stay safe.
Thank you. So
Yeah.
sorry for the inconvenience, my network issues.
No
No worries,
issues.
no worries. Like we have to consider them due to the pandemic. So yeah, no worries. Thank you and stay safe.
Thank you. Thank you.
Thank you.
Thank you, guys.